When you really stop and think about the universe, the numbers are just staggering. Our galaxy has hundreds of billions of stars, and the observable universe, it has hundreds of billions of galaxies. It's almost impossible to wrap your head around that kind of scale. And in all of that mind-boggling emptiness, there's this one question that's been nagging at scientists for decades. It's a simple but profound puzzle. Where is everybody? That's it. That's the question that physicist Enrico Fermi supposedly asked that launched 1,000 theories. And the logic, it seems pretty solid, right? I mean, tons of stars in our galaxy are way, way older than our sun. So if life isn't some total one-off miracle, civilization should have had plenty of time to pop up, figure out interstellar travel, and, colonize the galaxy. But when we point our telescopes out there, all we get is silence. So where is everybody? Well, today we're going to investigate two really surprising solutions. And the first one is that we've been telling this story all wrong from the very beginning. Yeah, so the first part of our little cosmic detective story here is a classic case of mistaken identity. It turns out the so-called Fermi Paradox, it isn't really Fermi's idea at all. So, according to the people who were actually there, at that famous lunch back in 1950, Fermi's question wasn't coming from a place of, I don't think aliens exist. It was actually the total opposite. He was pretty sure they should exist, so he was questioning the one big hurdle stopping them from paying us a visit, the insane, mind-boggling difficulty of traveling between stars. He was asking about the how, not the if. For Fermi, the real puzzle wasn't a lack of aliens. It was the ridiculous challenge of just crossing that much space. Okay, now this is where it gets really interesting. Look at this timeline. The phrase Fermi's paradox doesn't even show up in writing until 1977. That's a full 27 years after Fermi asked his question. And look what happens right before that. In 1975, a scientist named Michael Hart publishes a much more aggressive, much stronger argument. So the paradox we all talk about today, it wasn't Fermi's idea at all, it was Hart's. And this chart just lays out the difference perfectly. Fermi was skeptical about the how. He thought travel was probably too hard. But the Hart-Tipler argument, which is what the modern paradox is built on, it makes this huge assumption that for any advanced civilization, interstellar travel is basically a given. And from that one assumption, they conclude that since we don't see any visitors, nobody must exist. I mean, these are two completely different ways of thinking. So what this all means is that the Hart-Tipler argument isn't even a real, true logical paradox. It's a type of argument called a reductio ad absurdum. Basically, you take a premise, like aliens exist, and then try to show it leads to a ridiculous conclusion. But, and this is the key, this kind of argument is only as strong as its assumptions. It's kind of like saying, my friend isn't at this party, therefore my friend must not exist. It just completely ignores all the other possibilities. The Hart-Tipler argument only works if you believe galactic colonization is 100% inevitable for any advanced life. And honestly, we have no idea if that's true. Okay, so let's just put a pin in our first solution. We've been giving the credit to the wrong guy for an idea he didn't even have, and we've been calling it a paradox when it really isn't one. But believe it or not, that historical mix-up is only half the story. The second solution is, well, it's even bigger, and you find it buried in the math. All right, let's move on, because the real reason this paradox has felt so powerful for so long isn't just a simple case of mistaken identity. It's a fundamental mistake in how we've been doing the calculations all along. So this is the famous Drake equation. It's the go-to framework for trying to estimate how many alien civilizations might be out there in our galaxy. You just multiply all these different factors together, everything from the rate of star formation to how long a civilization might last, and you get a final number, n. It's actually a brilliant way to organize our ignorance. But here's the twist. The equation itself, it's perfectly fine. The problem is how we've almost always used it. For decades, scientists and enthusiasts would just plug in a single best guess for each one of these factors. And that one simple mistake, that's what creates the illusion of a paradox in the first place. See, when you do it this way, this point estimate approach, you end up multiplying one guess by another guess and then another guess. The result you get is a single number that looks really precise and confident, like there are 10,000 civilizations in our galaxy. And that number creates this really powerful expectation that we should be seeing someone. So when we don't, we're left scratching our heads with a paradox that was basically born from a false sense of certainty. Okay, this slide is absolutely critical. It's from a groundbreaking 2018 analysis. Using the old best guess method, the chance of us being alone in the galaxy is practically zero. You're basically guaranteed to have a paradox. But when you replace those single guesses with a range of possibilities that reflect how much we don't know, the chance of an empty galaxy jumps up to over 21%. The answer changes by 42 orders of magnitude. The paradox just evaporates. So, what happens when we take this more honest approach? Actually modeling our own scientific ignorance and apply it to the real Drake equation? Well, what the research shows is that while we're getting a much better handle on the astronomy stuff, it's the biological factors where the real uncertainty is hiding. Specifically, that one factor, FL, the fraction of habitable planets where life actually gets started. Our scientific uncertainty about that one single step is just astronomical. It spans hundreds of orders of magnitude. We just flat out don't know if life is a cosmic sure thing or a 1 in a trillion miracle. And the moment you properly model that enormous uncertainty, the conflict between what we expect to see and what we actually see just dissolves. The paradox wasn't some deep feature of the universe. It was just a side effect of our own overconfidence. We basically created a puzzle by pretending we knew a whole lot more than we really do. In fact, the analysis from that 2018 paper by Sandberg and his team came to this absolutely staggering conclusion. When you model the scientific uncertainty correctly, there is a 52% chance that we are the only intelligent civilization in the entire Milky Way. And get this, that's our starting belief before we even factor in the evidence of that deafening cosmic silence. So, if the paradox is really just based on a historical mistake and a mathematical error, what does the silence actually mean for us? Well, this updated perspective, it changes everything. This is the big shift. That eerie silence out there isn't a paradox we have to solve. It's data. It's the Fermi observation. And as this table shows, when we update our 52% starting belief with this powerful new piece of evidence, the simple fact that we don't see anyone, the probability that we're alone in the Milky Way just skyrockets to 99.6%. Now, this leads to a huge and frankly really optimistic takeaway. For decades, one of the most popular solutions to the paradox was the Great Filter. This idea that some inevitable catastrophe, like nuclear war or climate collapse, always wipes out civilizations before they can reach the stars. The silence was seen as this dark warning about our own future. But this new way of looking at the numbers suggests that's probably wrong. This completely flips the script. The cosmic silence isn't a dark omen about our future. No, it's powerful evidence that the Great Filter is actually in our deep past. The hardest step wasn't surviving our own technology. It was that monumental, nearly impossible leap from non-living chemistry to life itself. The silence isn't telling us we're doomed. It's telling us just how precious and unbelievably rare we are. Which leaves us with a final, and honestly, a much more profound question. The old paradox had us all looking up at the stars, asking, where is everybody? This new understanding, it forces us to look back at ourselves, right here, and ask, if we really are the galaxy's only glimmer of consciousness, what on earth do we do now?